So I'm Xufei Yang. I joined SDSU last year, 2019, as assistant professor and extension environmental quality engineer in the ABE department. So I'm an engineer guy, probably an outsider in this group, I guess. So thank you for having me here to update what I did and what I'm doing at SDSU. So on the extension side, my work in the last school year was mostly observing, learning, and plus some routing extension work. So I attended several extension workshops and gave presentations. I was the guy who presented the air quality and odor during the CAFO training workshops. My routing extension work also include virtual face-to-face meetings with producers and builders and equipment suppliers regarding an air quality, ventilation, and structural issues, basically engineering questions. For example, how to determine odor setback distances using the South Dakota odor footprint tool. Also tied with odor setback distances, last year we updated the South Dakota odor footprint tool factor sheets. I also wrote another one about the potential issues of using portable dust meters in livestock barns. All those publications were a joint effort between me, Ryan, and Bob. They have been extremely helpful since I come to Brookings. I also wrote some articles for local journals. For example, I wrote an article for the Sioux Nation Ag Center in Sioux Falls about a dry handling system of livestock manure, which is a quite interesting development in academia. For example, in North Carolina, people are trying to use dry handling systems, drying and pelletizing, for swine manure to increase the transportation distance before land application. Moving to research, so my group is quite small, but we are working in 3 different areas: odor and air quality, which is my specialty, Internet of Things, IoT applications to livestock production, and livestock waste management. In the following slides, I will be briefly talk about some finished and ongoing efforts. So the first project was vertical biofilters for odor control from swine barns. And this project was sponsored by the US Pork Center of Excellence. The project PI was Dr. Bob Toller. So through this project, we had 3 undergraduate students, and they studied the moisture content and airflow reads and different spots of vertical biofilters. As many of you know, moisture contents of filtration media, for example, wood chips, is critical for the odor mitigation performance of biofilters. So what we found was neither the moisture contents or airflow rates of filtration media were uniformly distributed with the 2 biofilters we built at the on-site swine farm, SDSU and Swine Research and Education Facility. So the students further studied the possible reasons and made some recommendations for future vertical biofilter design, and they presented their discoveries at the ASABE 2020 annual meeting. So ASABE is American Society of Ag and Biological Engineering, which is basically my profession. I was also involved in another air quality project. Once again, it's for odor mitigation and particle mitigation from swine barns. And this project was led by Dr. Erin Cortes from the University of Minnesota. So basically, this system has a fabric wall, and between the fabric wall and the exhaust fans are 2 metal wires energized by very, very high DC voltage with the voltage, dust particles and gas molecules become charged and ionized. As a consequence, they would be more easily captured by the fabric wall due to electrostatic force. My work in this project was largely particle monitoring, so we set up some monitors in the field to study the particle concentration before and after the air filtration system. We also did a field survey, okay, to measure particle concentrations downwind at multiple points from the swine barn. Instrumentation is my specialty. I've been working on it for many years. One ongoing project in my group is to evaluate low-cost particle sensors for their performance in livestock barns. Why? Multiple reasons. First of all, low-cost particle sensors are becoming more and more popular. So if you take a look at this year, the forest fire smoke map in the United States, actually over 2/3 of particle concentration readings are from low-cost particle sensors. So it's possible in the future your neighbors or some other guys may use those sensors to play against you. The second, if you buy a handheld particle meter for farm safeguarding purposes, nearly all the particle meters on the market are made from the low-cost particle sensors. And people knew those sensors could be inaccurate, but for livestock barns, what we want to figure out is first, which sensors are good, which sensors are bad. Second, if none of those sensors are accurate, what levels of measurement bias they could create. So we have done the coding, wiring, and packaging of those sensors. As you can see from this figure, we have a bunch of sensors to measure particles inside swine barns, and we are going to do the field measurement in the coming month. The second area of my research is Internet of Things, IoT. So what is IoT? IoT is a network that collects a variety of devices to the internet to promote data collection, exchange, and analysis. So IoT is nothing new to dairy farms because nowadays most dairy farms are pretty well automated. But for swine production, IoT applications are something new, are something at the very beginning stage. So this is an area we could and we are willing to contribute, okay, through extension and research. So IoT system has 4 physical layers. So ending devices, monitoring device, or control devices, and then you have IoT gateways and network servers to collect and distribute data. At the end, you have application servers which basically host the databases for data management and web pages or mobile apps to interact with users. So our work at SDSU focuses on end devices and system integration. So one of the systems we built here in my group is for remote monitoring of water levels and water temperatures in rangeland water tanks. So not for swine barn, but it's a good example to show you how our IoT system works. So at the bottom left is a monitoring device. Okay, so this monitoring device has an ultrasonic range sensor to measure the water level. Okay, and waterproof temperature probe to measure the water temperature near the surface, whether the water is frozen or not. So the sensor node has a LoRa radio module, as you can see from the antenna, so which can transmit the data a couple of miles, several miles away. So the sensor node, the monitoring devices uses a battery, uses a 5,000 milliamp hours battery and can run for over 2 years. So on the right side is a very simple, free, zero cost web page, which allow a rancher to browse the real-time water level and water temperatures from his cell phones or computers anywhere on this planet. So a similar system can be built to measure manure level in deep pits or the propane usage on swine farms. So on the showing the picture on the left side is a commercial manure level, not manure level, liquid level monitoring device. So it has an ultrasonic sensor to measure the level and a LoRa radio module, the antenna to transmit the data. So on the right side, it's a liquid level meter, but different from the left side is the sensor, the white circular one can be attached, can be glued outside at the bottom of a propane tank or a water tank to measure the liquid level inside. Okay, so to build a system which allows you to remotely monitor those parameters, one thing you need is a gateway, which is typically a few $100. And you can install the gateway in your house or in your office. And with that, you can have a well-equipped monitoring system for your swine farm. And one thing I want to say is a single gateway, a few $100, can cover several miles and can support over 100 devices. So it could be a good investment to some swine producers. And as an extension specialist, so it's our duty to develop some extension documents to guide producers regarding how to set up the systems, and we are going to do it next year. So other IoT projects in my group, first we built an air quality monitoring device to measure hydrogen sulfide, particles, carbon dioxide, temperature and humidity inside barns. This system is largely for research purposes. We also built a low-cost device to measure air temperature inside barns, which can be useful for heat stress management during summer. We are also retrofitting traditional ventilation controllers to enable the remote monitoring of the status of fans, heaters, and curtains. So anyhow, we are trying to build an improved data infrastructure for future livestock, including swine production. The last area we're working on is nutrient recovery from livestock waste. My graduate student, Augustina Otabuti, is trying to use algae to recover phosphorus from swine waste. So right now, she is cultivating algae in the lab, and she will keep doing that until she gets enough algae for swine wastewater testing. The algae can be harvested as a fertilizer, or can be converted into value-added products, for example, biofuels. In addition to algae, I'm also collaborating with other researchers here at SDSU in testing electrochemicals methods, for example, electro deposition for phosphorus recovery from swine wastewater. We recently had 2 projects funded by the National Pork Board and the U.S. Pork Center of Excellence. They just started, so there's nothing to report at this moment. And hopefully next year I can give you guys some updates about those 2 projects. Once again, thank you very much. I'd like to take questions if there's any.
Okay, are there any questions? Anybody wanted to enter into the chat? I do not see any. Thank you very much, Xufei.
Thank you.
All right, this is coming to the conclusion of our day. Again, I want to acknowledge our sponsors, South Dakota Pork Producers Council, Adiseo, Marsh and McLennan Agency, and Xufei Products for their sponsorship of SDSU Swine Day. Again, as Bob said, the Swine Education Advisory Council members meeting will start shortly, and you should have received the link to join that meeting. I want to acknowledge those members, First Bank and Trust, and the Fishback Financial Corporation, the DeRushi family, Compier Financial, the Minnesota Pork Board, Minnesota Soybean Research and Promotion Council, South Dakota Pork Producers Council, and the South Dakota Soybean Research and Promotion Council. And thank everyone, especially those groups mentioned, for your support of the South Dakota State University Swine Education and Research Facility. I look forward to meeting with you again and hopefully in person next year for SDSU Swine Day. Thank you for attending today and have a good day. Thank you.